Hello and welcome everyone to this new series about generative artificial intelligence or generative AI. In this series, I will focus on large language models, or abbreviated as LLM and S for the plural, and also image synthesis. So generative AI is a very wide subset of artificial intelligence method that uses generative models to produce text or images or videos or any other kind of data. Usually these models are pre-trained using a huge amount of data. After that, it's fine-tuned for certain tasks. For example, large language models, usually they are trained on trillions of tokens of the websites collected from the internet, and then they may be fine-tuned to do some tasks like sentiment classification. So we can give them a sentence and ask it to classify it. Is it positive or negative? Or it can also be used question answering, as we will see, and so on. In this series, I will not go into the architectures of generative models or LLMs. Rather than that, I will be focusing on using those models. So in the first video of this series, we will look into online tools such as ChatGPT, Gemini, and Copilot. So this is ChatGPT, which is built around LLMs. So in ChatGPT, you know it, we can ask it a question, for example. So what's LLM? And then in a few seconds, it will give us an answer that LLM stands for large language model. And it also writes what tasks are done using large language models. For example, natural language understanding, natural language generation, conversational AI, tasks like writing articles and summaries, code generation and debugging, translation, sentiment analysis, and I think there are even many more. I will also show how we can use these online tools to understand image and summarize text. Then for the rest of this series, I will focus on open source models and how we can download them and run them locally using tools either like command line or using Python scripts or web interfaces. So the most famous open source model is the Llama model from Meta, and there are multiple variations of this model. So now we can already use the Llama 3.3 model. This can be used directly using the UI. However, I was not able to run it since it seems not to be allowed in Germany. So this is the Llama website. As you can see, so we have Llama 3.1, 3.2, and 3.3, the newest one. And we can download these models, and we also have this link to try Llama on Meta AI. However, when I click this, I get this message that it's not available in my country. However, that will not be a problem since actually I will be focusing on how to run these models locally anyway. So I will first show how to do that using the Ollama, which I found it to be the simplest method. So we just download the Ollama and install it. And there is a nice command line interface. Maybe I can show you this command line interface. So here I opened Windows PowerShell. I already have Ollama installed on my computer. So we can write Ollama help, and then you can see all the commands which are available. So for example, we have this command list, which lists all the models which we already pulled from the internet. Let's try this command. I already pulled few models. So you can see here we have the name of the model, ID, the size, and the download date. From the size of the model, you can also see how large this model is. So this Llama 3.2 is tiny models. As you can see, it's like 1.3 gigabyte. So this, I think, 1 billion parameter. There are models which are like 7 billion parameters, like these two here, which range from like 3.8, as you can see here, to almost like 5 gigabytes. And there is larger models, 70B, which stands for 70 billion parameters. And you can see it's like a very huge model. On my PC, I have NVIDIA 4070. So I opened here the task manager. You can see here the type of my graphic card. This is a good one, but of course there are much better cards like 4080 and 4090, for example. And of course there's computers which supports more than GPU. And the other options is to use the cloud, and then you can use as much GPUs as you want, but of course the cost would be high. So let me put this here to the side, and let's try to run one of these models that I already installed. And for that we use the command Ollama run, and then we write the name of the model. So let me run this model here. Now click enter, give it a few seconds, and now the model is already loaded. So you can see now the memory usage here in this model, so which is 4.7 gigabytes, already took more than half of the memory which I have. This model is like 7 billion parameters. So if we are using float with 4 bytes, that will take up to 7 times 4, so 28 gigabyte of memory just to store these 7 billion parameters. We will talk more about this when we want to run these models. So now let's ask it the same question which we asked ChatGPT. You can keep an eye here on the GPU usage when I press enter. So I will press enter now. Notice the high activity of the GPU because this is running really locally on my GPU, and you can see here the output. Now this gives us like multiple options. So large language model and giving more details about it. Then it says that limited liability member could be an option. Low library master, I don't know what's this. So I would say it looks very great. Let me close this model. For that, we use simply /by, and let me run the 1 billion parameter model, this Llama 3.1. And let's ask it the same question. So what's LLM? So now it's answering us about Llama. So he thought we are asking about Llama. Maybe we can make it now more specific. Yeah, so don't forget that this is a smaller model, so it have smaller capabilities anyway. Let's ask it what's a large language model. Give us the correct answer, so it helps us to understand and generate human-like language. Then it talks about the characters of large language models, massive training data, complex neural network, scalability, that's because these models are really very huge, flexibility, and here it's talking about the fine tuning and so on. I will also show how we can run Ollama using Python code, using HuggingFace API. I will talk a little bit about the HuggingFace website. So this is HuggingFace. It's the portal to go whenever you want to search for available models for certain tasks. As you can see here, it has a huge amount of models, and also it have like data sets, and it also has spaces where you can run models. I will just show for now the models. You can see all the kind of models that you can search for. As you can see here on the left, those models are categorized by tasks. So we have like multi-modal where you have like an input audio text to text. So you have inputs as audio and text and output as text. And here you have input as image and text, and you're outputting text and so on. I mean, really a lot. This is like the natural language processing. And here you can see under natural language processing, we have many tasks. For example, text classification, question answering, translation, zero-shot classification, summarization, many others. Yeah, and you can see it's really huge. So if we click text generation, see the number of the models, and you can see here we already have the Llama 3.3, which have like 70 billion parameters instruct, yeah, and we have the Llama 3.2, 1 billion parameter, which we already were testing now, and many others. Hugging Faces also have a Python library, which is very helpful and simple to use, and I would say it's like very popular. So this is like includes some packages like transformers and other packages which will help you even to train and fine-tune models. So after running these models locally, we will look at prompt engineering. So basically how we can retrieve information from these models, and for that I will be using Python here mostly to show how we can do prompt engineering and how we can also do retrieval augmented generation. Those are two ways which we can use an already fine-tuned LLM to extract information. So for general information, you can directly use a prompt as we did already now, and the LLM will give you the answer. However, for some tasks, maybe the LLM is not trained on the data which you are asking about. So if you have like a private data, if you are working for a company and you want to ask question about private databases, maybe database which contain your sensitive information such as employees, salaries, and other stuff, such information should be local, so it cannot be accessed by Meta or other companies which make these large language models, so it will not be used for the training. Then basically the LLM does not even know anything about this information, so we have to feed it this information in some way. So that's why we use this retrieval augmented generation. And retrieval augmented generation is the method to go when we want to ask an LLM about your private data without training or fine-tuning, so without changing this LLM. The second way to do that is actually to fine-tune your LLM. So again, we have our sensitive data and we want to query an LLM about it. And in fine-tuning, the way to do that is by you find first the model which you think the best fit for your task. So if you want, for example, to ask a question about this data, you search for a LLM which already may be fine-tuned for question answering, and then you again fine-tune this model using your sensitive data so it can really answer questions about this data. So another way also to do that now is like memory layers. However, as you can see, I put this by the maybe, so I may talk about this and may not. So to be honest, I just started recently working with these memory layers, and I'm not sure if I will be able to have a good material to present for that. If yes, then I will present it. If not, then maybe in another series. So in this series, I will also have some videos about image generation. The open source models for image synthesis, which we'll be using, are provided from stability.ai. And as you can see here in this website, if we hover over the models here, you can see there are images, videos, audios, and 3D also. My focus in this series will be on the image. And you can see now the available models. As you can see here, we have Stable Diffusion 3.5 here selected. As you can see, you have three categories here: Stable Diffusion 3.5, 3.0, and the SDXL. So we'll use some of these models to generate images. You can see also here some samples of this. And I will mostly be using the Comfy UI. So you can see here, I'm running Comfy UI locally on my computer. And this is the user interface. Inside this Comfy UI, you can define a workflow. So this workflow is built around this loaded checkpoint component here. If I zoomed in, you can see that this is an SDXL model, and this model feeds the different components of this UI, and we can generate images as much as we want. So just by clicking this Q prompt here, let me now zoom in on the prompts. So I said like supernova, in space, colorful. So this is what we want to generate. Let's say realistic also. And here are the negative prompts, so things which we don't want to appear. So we don't want this image, for example, to be bad artist, not embedding bad hands and other stuff. This is usually if we are generating human. So I think that's okay. Let me now zoom out. So now when I click on the Q prompt, so now you can see the sampler is generating, and now it's already done. So we already have an image, and we can repeat that. This looks nice. Not very much, I would say. So this looks good. Then finally, if I have more time, as I said, I will have some videos about stuff which are already experimenting with, such as animation, music, and 3D. If you find this interesting, so please stick with me with a month or two. I hope to be finishing the content of this series. If you have more things in mind that you want me to make video about, please write it in the comment. And if what I said here is something which you like to learn, then subscribe so that you don't miss the videos. And that would be all for this introduction video. Thank you for watching, and I hope to see you in the next video. Bye.